Good afternoon, everyone. Today, I am taking you through the fascinating history of early high-speed technology development, mainly as it unfolded here in Lappeenranta. Our story begins in the late 1970s, sparked by an international energy conference and a visionary idea to convert waste heat into electricity. The genesis of this research lies in the 1976 Total Energy Conference in Copenhagen. Professor Wilson and his research group presented an idea for a small-scale power plant based on the organic Rankine cycle, ORC, producing both electricity and heat. This concept resonated with the young Jaakko Lariola, who attended the conference. In 1980, while acting as substitute professor of LUT, Lariola, together with Professor Sarkomaa, received funding for a project. The goal was ambitious: to build a 30-kilowatt prototype turbogenerator of an ORC power plant. The project officially began in 1981, and here we see the early sketch from the prototype. Lariola traveled to Oxford, where Professor Herbert Sixsmith guided him into the secrets of gas-bearing technology. Around this time, the recently retired Professor Esa Vakkilainen started his master's thesis work on the project. And here we have the electric generator, turbine, the feed pump, and radial bearings. Professor Tapani Jokinen from Aalto University designed the high-speed electric machine, which was in this case the generator. Technicians Jouni Ryhänen and Ilpo Taipale were in charge of manufacturing the gas bearings. Their skills in producing these bearings earned them the Master Craftsman Award from the Academy of Technical Sciences in 1982. The 30-kilowatt high-speed turbogenerator feed pump itself was completed in 1981 and performed roughly as expected, rotating at 30,000 RPM. This early success paved the way for big news. A press conference was held to present the benefits of the project, called Pianosvoimala, micropower plant. The small team managed to get funding for the 100-kilowatt prototype power plant. Around this time, people started to talk about high-speed technology. While the ORC power plant was the primary focus, LUT researchers saw potential also in other areas. In 1983, I started with Reijo Päivinen the research on a high-speed compressor. This led to a research project with Megamer aimed at developing a low-pressure air compressor, still with a high speed. At the same time, Juha Pyrhönen conducted the study on a small gas-bearing high-speed motor. This motor reached a remarkable speed of 150,000 RPM and is still operating today. It was meant to be a laser scanner. Petri Sallinen joined our team and would become our tribology guru. Building a 100-kilowatt ORC prototype at LUT proved to be quite a challenge. The team, led by the optimistic Lariola, learned that constructing a power plant is far from simple. After hard work, the unit successfully produced electricity to the grid in 1985. It was fueled by liquefied petroleum gas and burned in a self-designed matrix burner. The unit was fully manual and needed 3 operators to be functional. So as you see, so we have decreased the number of operators from 5 to 3 now. But more was to come. This Kuopio-based ONC unit, equipped with a frequency converter, fed electricity to the grid in 1989, and this power plant was fully automatic. But it faced problems, including dirt and water entering the process from sawmill piping, first damaging bearings and finally short-circuiting the stator of the generator. The working fluid, R114, also presented limitations due to its ozone-depleting potential, making it unsustainable in the long run. The frequency converter technology at the time was hard on gas bearings. Therefore, a decision was made to use liquid bearings. This maintained oil-free operation while providing increased load capacity for the bearings. A crucial step towards making business was securing an industry partner. Already in 1981, Laarila had filed patent applications for the high-speed turbogenerator. 3 patents were eventually granted, and the main patent was also validated abroad. Founding of High Speed Tech Limited took place in 1988 by these gentlemen. Initially, the company existed on paper while actively seeking suitable funding. A major turning point was the contact from the oceanics unit of Rauma Repola, which needed small power plants for deep-sea applications, like the Mir submersibles capable of operating at 6 kilometers depth. And we all know that they later appeared in the Titanic movie. Jarmo Alamäki was the project engineer from our side. In 1990, Rauma Repola bought the High Speed Tech company. Kauko Helevirta became the first CEO, and several key LUT staff members transferred to work at HST. Timo Kytömäki identified aeration compressor as a potential application, which became the company's main product. HST used Vacon IGBT converters for its aeration compressors. Developing the oil-free compressors into a commercial product required significant efforts. Early models used radial gas bearings and axial magnetic bearing, while later models fully adapted magnetic bearings. The company operated in 3 cities, Tampere, Espoo, and Lappeenranta. Also, researchers at Lappeenranta and Helsinki universities worked with HST, some full-time and some part-time. Once a month, we had meetings together, first on a rotation basis, and then decided that people will travel to LUT campus in Lahti. Research in the 90s also explored numerous other applications, notably the reversed Brayton cycle, high-pressure pumps, and high-speed refrigeration machines. And there would be other companies. Jarmo Alamäki left HST and founded Rotatec Finland in 1996. Rotatec focused on medium-speed electrical machines utilizing Pyrhönen's electric motor design. Ecopump, nowadays Rantec, provides vacuum compressors for the paper industry, and was Rotatec's main customer. Rotatec's motors operated at lower speeds, around 10,000 RPM, and covered a power range up to 1 megawatt, and used oil lubricating bearings. Rotatec was later acquired by Vacon and is now part of the switch drive systems, and they focus on wind turbine generator. The OSE concept also eventually achieved a real business case. The Dutch company Triogen acquired the necessary rights from HST. A 175 kilowatt unit built into a standard container was completed at LUT in 2003 as a start of their success story. This unit was tested in lower than 30 degrees cold. Juha, previously from the lab of Tapani Jokinen, worked for the Sundyne company. Jouko Peussa, previously heading low pressure project at Megamer Hydor, worked for Sundyne's partner Compare. They contacted us and HST in 2002 for design of a high pressure compressor. A commercial high pressure compressor using magnetic bearings was launched later. Nowadays, it is a product of Gardner Denver, which also owns Runtec. Beyond the commercial successes and technological advancements, this extensive project has also yielded significant academic results. In addition to numerous publications, it has led to the completion of many doctoral dissertations. This strong academic foundation, coupled with dedicated research and development efforts, was instrumental in defining and advancing the field of high-speed technology. It's a testament to the power of university research and collaboration in driving technological innovation and creating new industries. This history demonstrates LUT's pioneering role in establishing important engineering field in Finland and internationally. This graph is only from the first 30 years, but shows quite significant in the research. So, from an initial idea sparked by an international conference in 1976, through challenging prototype developments, the research at LUT culminated in successful commercial ventures and academic contributions in the 1990s and 2000s and beyond. The story of high-speed technology is one of the persistent innovation, crucial partnerships, and the dedication of many talented researchers, engineers, and technicians. It's a proud chapter in the history of Lappeenranta University of Technology and its impact on industry. And with this image, I thank you for your attention.